Hello everybody and welcome back to another visual pattern challenge. Here's our pattern today. Here's step 1, which actually doesn't have anything in it. Here's step 2 and here's step 3. Your challenge is to predict the number of these green cylinders in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of cylinders in any step at all? So that's your challenge. If you'd like to accept it, pause the video and work it out. All right, so this is a little bit of an odd one because we don't have anything to begin with in step 1. Step 1 just seems to have 0 cylinders in it. And then we get 3 here in step 2. And then we've got 6 in step 3. So, you might be tempted to say, well, here it's 3 and here it's 6, so it's doubling. Maybe it doubles to 12. But you have to take step 1 into account. If you double 0, you don't get 3. So we're not doubling every step. To me, it looks like we're maybe adding 3. So we go from 0, we add 3, we get 3. If we add 3 more to that, we get 6. So I'm thinking we would just add 3 more cylinders on top of what we've got in step 3 for step 4. And that would be 2, 4, 6, 8, 9 cylinders in step 4. So that's my prediction for step 4. Let's take a moment to analyze these numbers. I'm going to make a chart with the step number and the number of cylinders. So in step 1, we've got 0. In step 2, we've got 3. In step 3, we've got 6. And in step 4, we're predicting 9. If we take the difference between each step, 3 minus 0 is 3, 6 minus 3 is 3, and 9 minus 6 is 3, we get a constant right away in the differences. That means this is a linear equation. The rate of change in a linear equation is constant. That means it goes up by the same amount each step. And we can use this formula, the formula for a line, to model that. And what we do is we take this difference, this rate of change, and we put it in for where the slope would be in a line for the m. So y equals 3x. And then this plus b part, well, we don't really know what that is until we try things out. Now, the x in this equation stands for the step number. So if I were to take this stem of our equation, y equals 3, and instead of x, I'm going to put in 1. So y equals 3 times 1. That is supposed to give me the number of cylinders. It doesn't, because the number of cylinders here is 0. 3 times 1 would be 3. To get to 0, I would actually need to subtract those 3 away again. And that is going to be our b. Our b is a negative 3. So this is our equation now. Let's test it to make sure that's working. So in step 2, I would say y equals 3 times 2 minus 3. 3 times 2 is 6, minus 3 is 3. And that's how many we have in step 2. How about step 3? Y equals 3 times step 3 minus 3. And that's 3 times 3 is 9, minus 3 is 6. Yeah, that's how many we have in step 3. So we can be sure our equation is a good one. Y equals 3x minus 3. And to get the last piece here, the number in step 43, we can just plug 43 in for x, for the step number here. So y equals 3 times 43 minus 3. Okay, so what's 3 times 43? Well, 3 times 40 would be 120, and 3 times 3 is 9, so 129 minus 3 would be 126 cylinders in step 43. Well, how did that one go for you? Did you decide that this was a linear pattern, or did you think doubling was going on? Did you get 9 for step 4, or did you get something else? I'd like to know. Thanks, guys.